And in your list of web references, there's an 8-pager. It says called An Introduction to the Guidebook. So it's really great when you have 6 years later because you kind of look back in terms of the lessons learned, and so the purpose of the introduction then is to hit the basic highlights in terms of what you should be getting out of the guidebook. And I was thinking back to some of the comments you made, Kate, which is we don't expect everybody in this room to read the guidebook from cover to cover, because it covers quite a spectrum of perspectives. You've kind of got to get a sense of where you want to learn from, and that's what the introduction will help you, is kind of just capture those key thoughts so you'll know where you want to go with it. And I'm coming back to the table of contents in a moment. Hold that thought, because the guidebook, beyond the guidebook, well, the guidebook, the emphasis was on rainfall capture, volume control at the site scale. And now after 6 years, we have the benefit of all the lessons learned, experience gained in terms of what we've done. And now we're ready to do the next push, which is, okay, now how do we relate how you've managed volume on the ground, on the site, to what you see in the stream. And so using, Sandy, the example we saw today, we were kind of up in the bush, right, in a detention pond. What is the relationship between what was taking place on that site and the estuary as we drove by and the bus coming here? That's where we're at. But we can't get there in one leap. So part of like today and then October 24th and November 21st then is to create some of those building blocks which will help you get there here in this room, but getting there is going to take place after November 21st. This is a graphic I created a decade ago, and it kind of captures a lot. Am I blocking you very much? Can you see it? Okay. Because back in 1998, when the science on the biology side was just coming together out of Washington State in terms of how land use was impacting on the stream corridor, and for British Columbians especially, the stream corridor is it's the canary in the coal mine. And so, what we did then was we were characterizing the decades, and this is the significance of saying the 60s, was protect properties, but in terms of piping, because I always call it the City of Vancouver solution, right? They culverted all their creeks, now they're dilating all their creeks. And then into the 80s, sort of in reaction to the 70s, when we were now building ponds, but the ponds didn't reflect a full understanding of what was happening in hydrology, right, Ian? We were still having erosion. So you had a pond, you were shading peaks, but you were still eroding because you size was wrong in. And so, a decade ago, we were at a point where we were in a salmon crisis. Just think back, it was only a decade ago we were talking about the salmon crisis, and we were looking at this whole biodiversity and abundance issue and saying, well, the 60s and the 80s, we were losing biodiversity and abundance, coming back to the, as you're our environmental person. So when you ask the question, well, where do we want to be? Well, we don't want to be going backwards. And we said, well, how do we move forward? Well, I can tell you in 1998, our philosophy in British Columbia was, if we can hold the line, we thought we'd be doing well. If we could stop more erosion, that was considered to be a success at the time you started putting in your first ponds. And so that became a 20-year vision. And then we said, well, if we can be successful over a 20-year period in holding the line, well, maybe we can begin to think in terms of a 50-year vision and making things better. And this actually became the basis. City Kelowna was the first council to base a policy decision on this graphic, followed by Burnaby, Port Moody, Coquitlam, where council said, okay, we buy into the fact you got to have a 20 and a 50-year vision. And I'll tell you, in 1998, we put a big affordability threshold counter good, and we said, what do you think we really can do? And we said, we don't know. We weren't optimistic we could get into making things better. And then, by the way, this graphic is starting from a developed perspective, because obviously, if you started with a virgin watershed, you're going this way. But this had been the reality, right? This had been our reality in 1998. This is what we were used to seeing. Start with green watersheds and progressively lose things. Well, a decade later, my experience, what I'm telling you is, I believe what we thought was unachievable a decade ago is within our grasp. Because that whole change of thinking in terms of our site development practices is what's given us the optimism that when we think differently, we come up with different solutions. That's why I think the pond was, those two ponds in sequence is great, because you do see, just in the look and feel, you see the difference between early 90s and a 2000 design. It's just, I think several times you said, you basically use the design with nature language. I mean, I'm not saying that those two ponds are the ultimate example, but I'm saying in terms of having a picture, which, in your mind as to what we're talking about, yeah, it's a different approach in terms of what you're trying to achieve. And that's what gives us confidence that, you know what, the way we develop land, we actually can do a lot better. We didn't, a decade ago, we did not think that. So, watch my time. Going back to 2000, why did we begin to turn it around? Because we started to understand our basic hydrology. We stopped thinking in terms of the rains once a year. Started thinking about, we know the volume is causing the impacts, how do we begin to manage it? So this was the first shift in thinking, which is when we said, okay, look at how many rainfall days we have and where the volume is accounted for. So when we looked at the 180 days of rain that we get in this region,
Appreciate that. 180 days.
Yeah. Well, I can remember, many years ago watching, you remember this before we had more choice on TV, I remember watching, whatever that was, at 7 o'clock, that show from Seattle Tonight. I always remember them talking about, in the Pacific Northwest, every second day it's either raining or gray, right? And I thought, oh yeah, now I can tell you why. And that's what really brought it home about most of the rainfall is very small, and you got these other 10 or so events that are, were heavy and extreme. And that's the significance of volume that you were referring to, that you can sort of see that 3/4 of the rain falls in the lake showers. And then that led to the integrated strategy. And this is the graphic, this is the heart of the guidebook, because when you stop thinking in terms of just one solution, but thinking in terms of it's a combination of strategies. But you can't do it all at the site level, but you can do a lot at the site level. And then there are things you got to do at a neighborhood scale. That's what your ponds are showing. That's the neighborhood scale solution. And then the reality is when you get at a watershed scale, if it's the monsoon season and everything is saturated and it's all coming off, then you, from a public works point of view, you have to be able to manage the monsoon, right? So, but it was breaking the thinking down into those three basic components. And it was my wife who told me when we were, if you look at the guidebook, the language is a little bit different. But when we refined this graphic publication in a professional engineering journal magazine, it was my wife who said, I'm talking like an engineer, and she was the one who started saying, well, what do you mean? Well, you're talking about light showers, are you? Because we had, major storms, small storms, that kind of stuff. But as a layperson, she could relate to light showers, heavy rain, extreme storms, but getting us thinking in terms of what we're trying to do. We're trying to keep rain on site if it's a site solution. You can't keep it all on site necessarily, so at the neighborhood scale, you're trying to delay it. And in the watershed scale, you don't want to cause flooding, so you're trying to reduce that potential. So that became a graphic, and that's where the water balance model became such a key tool, right? Because we didn't have the engineering tool to do the site solutions. Water balance model was a tool. Again, understanding how the rain falls, being a tool that you can play with different configurations of development. So say if I have a total rainfall, what can I do given constraints of ground and space and soils? Well, what can I do to alter that red? Is it going to be that much red, or is it going to be that much red? And once people can kind of see the visual, they can come up with different solutions. So, made in BC tool demonstrates the light hydrologic footprint. I'm not going to try and do a demonstration of the tool, other than to remind you that it calculates volume. Those are the parameters. When you go to waterbalance.com,